it, in particular in his marketplace. Tim.
Yeah, hi there. My name's Tim, run a little architecture practice just over the valley and also in London, and was involved in these buildings here back in 2017 and more recently on a little hemp building, a stone's throw away from here down the valley that you've probably all seen. So I wouldn't call myself a sort of veteran hempster like many of you are here today, including Alex Sparrow and Ian Pritchett. But it's been a good journey over the last couple of years, looking into hemp, and definitely convinced that it is the way forward. So from the early 19th century, historic construction and farming sort of used predominantly self-build methods of local materials with a low carbon footprint, and since then. Industrialization, we're now using a lot more synthetic materials. We've got huge pollution. Quite unbelievably, the sort of construction sector accounts for around 6% of GDP, yet it is responsible for 38% of emissions. When you put farming, agriculture, food processing with construction, we're talking about more than 50% of UK emissions. We've got a fight on our hands to stop and try and reduce climate change. So the time is now, and we need to act quickly. And we strongly feel that we should be using biomaterials, and hemp in particular, to start building our buildings from. So the big elephant in the room in building is embodied energy. Building regs have gone a long way recently to reduce energy in use, but understanding what our buildings are made from and what carbon we're emitting or storing in our buildings is very important. And we've been creating sealed boxes from mined materials that require huge transportation, require huge energy, particularly the sort of rigid PIR insulations and concrete and steel. And rather than mining our materials, we should be growing them and growing them more locally. So this is a building that was commissioned in 2006 by Lime Technologies, and it's a really good precedent, we think, for showcasing what hemp can do. So this is the Adnams Distribution Centre, where they store their kind of beers and wines and vinegars and whatever else they do. But by using this hemp and lime, they can create very, very stable indoor temperatures. It's also naturally buffers the indoor humidity, and this building uses very, very little, if any, sort of mechanical systems. It's a self-regulatory sort of internal environment. The hemp can give you these huge benefits of creating healthy, stable indoor environments. So the hemp crete is made from the shiv, or the hurd, which is the middle of the plant, mixed with lime, mainly, and water, small amount of white cement. And then you can create these hempcrete blocks, which gives you this ability to highly insulative performance, but also allows you to self-regulate internal environments, provides good fire resistance, good bug resistance. And picture here of the stem of the hemp plant that, as Lydia said, grows really tall, 4 meters tall. And the outside of it gives you this really strong fibrous material that we can make fibre insulation from. And this here is a picture of the inside of the plant, of the hurd. So again, not an expert in this, but the unique nature of the hemp plant gives you this kind of cellular structure of tubes and capillaries that gives you a very, very lightweight, breathable, insulative properties that provide good acoustic values as well. And to give you an idea of the sort of carbon absorption factors, if we take a conventional insulated cavity wall construction with blockwork on the inside and brickwork on the outside, we're kind of producing, we're emitting around 70 kilograms of carbon per square metre. But yeah, even with a kind of internal timber frame, you know, we're still emitting around 68 kilograms of embodied energy per square metre. But we then go to a solid cast in situ wall, and we're absorbing 35 approximately kilograms of carbon per square metre. So we're locking it away and creating this breathable aspect, this self-regulatory construction. Even if we, you know, give the house builders what they want with an external brick facade, an internal build-up, we're still at net, you know, we're still at zero in terms of the carbon absorption. So it's a very positive story. So, yeah, I think for us, in short, is the idea that we could create a sort of network of farming cooperatives where we grow, process and build with hemp locally gives you the sort of economic, full sustainable sort of benefit of hemp. And yeah, it's very interesting to think that, you know, with possibly 2 to 3% of the UK's arable farmland could replace the entire blockwork and insulation requirements of the UK, is relatively small amount of land that could fulfil that. So I think a bit of Ian here, but let us, you know, grow our buildings as we grow our food with care on local soil in service to future generations. That's the thing. So if there's any questions that anyone has.
Yes, so just a few, you said 2-3% of the land use, we could grow all our blocks.
It's really approximate, yeah.
Is that including all concrete that we use? So, like, can this replace the whole concrete industry?
So really, really approximately, I think we use about 10 million tonnes of concrete blocks a year. This isn't foundations or precast beams or lintels, it's just the block work requirements. Okay. So that, coupled with the rigid PIR insulation, is around 2-3% of the arable farmland. It's very, very approximate. Yeah.
And the other thing is, so you're using lime with hempcrete?
Yes.
So there's a carbon footprint?
There is, yeah. Yeah.
Your figures that you quoted for the sequestration thing, does that include the carbon footprint of the lime?
Yes. Yeah, I believe so. Yeah. And yeah, obviously lime's a naturally occurring product, but you have to heat it up a lot less than you do with sort of cement to get the same outcome. But yeah.
Can I just add to that? So one of the things that we wanted to stress in our project is, you know, you've chosen a number of products that you put into use in what we roundly call the hemp house, which you'll see presently. But all of these products are building, excuse the pun, into the landscape. And so if you talk to Chloe, who's standing up there with the black shirt on waving, she is looking at a whole range of different products, some of which use hemp lime, some of which don't. So in order to answer your question, you know, that's got a carbon footprint. If you wanted to have a completely carbon-based solution, then you could use some of the things that they've been building in the Natural Building Systems firm.
Yes?
I noticed in your slide you had 2 different depictions of the cellular structure of the hemp.
Yeah.
What do those 2 different ones refer to, and how might
Here.
they compare with like straw and what straw bale cross-section looks like?
So I'm not an expert in the cellular structure of hemp, but it's incredibly strong in comparison to straw. But Lydia is the
She's going to call me the expert now, and that's not actually. But I'm not a physiologist. But any botanists here, possibly not. what a plant has to do in order to grow, it starts off as a seedling and it grows and grows, and in order to grow, it needs the nutrients which it gets from the soil, which are the nitrogen, the phosphate and the potassium and all the micronutrients, and it needs water, and that water goes up through the system and it transpires out of the little holes in the leaves which are called stomata. And so there's a pressure that pulls it up, and the way that it arrives from the bottom, i.e. the soil, into the top of the plant is it goes through different vessels. So you've got your phloem vessels and your xylem vessels. So the xylem are live tissue which pull up the some of the
These are in here, the
micronutrients.
black holes.
On the outer, the xylem is usually on the outer, and then the inner is the phloem vessels, which are primarily involving pulling that water up through. And because it's growing really fast, it's got big, broad phloem vessels and xylem vessels, and that's what gives you, after it dies, that open structure, that corkiness. And so all of those spaces that used to be full of water, which was being pulled up into the upper parts of the plant, then become air holes. And as you know, if you've got a very open structure with lots of little air holes, it's a really, really good insulator.
Absolutely, yeah. Yes, hi.
Do you tend to use hemp on other projects also? I'm just thinking about the cost and
Yeah,
I think it needs the right client, right setting.
yeah, increasingly. I think it's quite, on the cost front, it's quite, I don't know if Ian's here in Pritchard, but he was saying, obviously Greencore Homes have developed this panelised system now. Their aim is to build 10,000 homes by 2035, and they're saying that at the moment, in today's money, it is cost neutral, you know, when compared to other things, other similar, conventional constructions. But, you know, you've just seen the crisis in the Middle East recently, and contractors stockpiling rigid PIR insulation. So, yeah, I think we're coming to a point now where even without scaling this as a UK-wide industry, we're already kind of getting close to a similar equivalence with obviously high petrochemical content. So, as I say, not an expert, but my feeling is that, you know, if this can be scaled, it could be cost positive. Yeah.
Well, we tried to use it on a job a few years ago, and by the time it got to the stage, this was the first thing which was weak.
Yes.
I think it just needs, you know, as I said, different line, different.
Yes.
Line rights.
I mean, I think, you know, one of the interesting things about hemp, particularly the cast in situ hemp, is the self-build benefit. You can obviously achieve building regs with 300 and so mil of cast in situ hemp, and if you're doing that yourself, then the costs start to get very very attractive.
But it's quite a nice product, and
you enjoyed working with it. Yeah. No, people. Paul, who built who built the barn of stone's throw away, loved working with it. You know, there's no kind of toxicity issues on site. Construction waste is obviously easily dealt with. So I plan to push it a lot more in the future. Yeah.
Thank you.
Yeah.
Can you talk through the solid wall construction slide?
Yeah, sure.
Where it's completely solid.
Yeah.
Timber stud in the middle, I think. No, not the next slide.
Yeah.
On the left. That one on the left.
Yes. So obviously, hempcrete is not load-bearing. There are companies creating load-bearing blocks. They've got a higher carbon content because of the binders need to change. So timber is an essential part of the build-up. So there's lots of different ways of doing it. I really recommend reading Alex Sparrow's book that talks about different approaches to the wall construction. But obviously a lot of them need to be shuttered. So here, you put the studs on the inside and then you remove the shuttering. I mean, with the barn that we've done, obviously one of the shuttering, the inside face of the shuttering was obviously retained.
Do you need to put membranes on that?
No. One of the peculiar things about using hemp is that there are no cavities. Everything is abutted. So on the there's a membrane on the inside of the stone, but there's no cavity. It's pushed right against the Cotswold stone wall with the hemp fibre and then the cast in situ hemp on the inside. Having the cast in situ hemp on the inside of the build-up allows you to more, to regulate indoor humidity and temperature.
Wrap that on the outside with stone. Could you? What about wall ties and things like that to hold the stone in place?
We on this barn, obviously, it is tied back to the stud-work with ties.
So it goes back to the start.
Yeah, something needs to support the but there's no cavity. It's kind of, that's the tricky thing to get, well, for me to get my head around was, due to me not having a cavity. But that's what gives you the breathable efficiency.
Effectively, you would build the stud wall, fix the ties to it, and then clad it, surround it
Yes.
with the hemp.
Yeah. And similarly, if you're doing a rain screen or a board on board, you'd have the counter battens fixed back to the stud with a breathable membrane.
Eager to move you on. So you now have 3 choices. Number 1,